Another application of our exponential growth is compound interest, and these are same thing in terms of formula. And so we're going to say that interest is compounded continuously if the number of compounded periods per year is increased indefinitely. And so that is that at every moment of time, the interest is building on some loan and pushing back into your principal amount. And so specifically, our continuous compound interest formula is the exact same as the formula for exponential growth. That is, the amount after some time t is equal to an initial amount, a sub naught, times e to the kt, but instead of k, I'm going to call it r for interest rate. So then let's say that $10,000 is deposited into a savings account at 4.6% yearly interest compounded continuously. We want to find the formula for a of t and a differential equation satisfied by a of t. And so we want to find the formula for a of t. Well, we know that a of t is going to be equal to our initial amount, which is $10,000, times e to the rate, the interest rate, but the interest rate needs to be in a decimal. So if I have 4.6%, percent is per 100, so 4.6 divided by 100 is going to give me 0.046, and so then my rate r is 0.046 times the time t. Well, and if we want a differential equation that satisfies a of t, remember that differential equations that we're looking for are y prime is equal to k times y. And so this is going to be a prime of t is equal to that constant k, but in this situation it's really r, 0.046 times the initial function, a of t. Alright, well now we want to know the answer to the question, how much money will be into the account after 3 years? So, well, we just need to calculate a of 3. Well, a of 3 is then going to be 10,000 times e to the 0.0466 times 3. And I'm going to round to 2 decimal places, so I get that this is $11,479.76. And so that's how much money will be in the account after 3 years. Now if we ask the question, when will the balance triple? And so specifically that's saying, okay, well, what is the time t when it equals 30,000? So set my initial equation equal to 30,000. That's 10,000 times e to the 0.046 t. So let's solve for t. Divide by 10,000. Divide by 10,000. I get 3 is equal to e to the 0.046 t. Take the natural log of both sides. I then get that 0.046 t is equal to the natural log of 3 divided by 0.046 divided by 0.046. I then get that t is equal to the natural log of 3 divided by 0.046, which I get to be approximately 23.9 years. And so that's how long it will take before it will triple. Now, different approach. I'm going to consider the differential equation because the rate of change, how fast is the balance growing, is y prime or a prime here. And so specifically I know that a prime of t is equal to 0.046 times the amount that comes out, but I know that the amount is specifically 30,000. And so since that's the case, I know that the rate at this specific time is specifically 1,380. Now I like doing it this way because it's a little easier on the calculation, plus it gives me the exact value rather. And so that's dollars at that exact moment. That's how much money is gaining in the account. Alright, so now we want to know what interest rate must you earn to have your money double every 4 years. Alright, so remember that our initial amount, A sub naught, is the initial. And we know that if we want to double that, that's going to be 2 times that initial amount. Okay, that's our double. And specifically, we want to know, we want it to double every 4 years. So we want the amount in 4 years to equal 2 times A naught. But then I can actually use my initial equation, or the general equation, which is equal to the initial amount times e to the rate, which we're trying to find out, times some amount time. Okay, great. Now I'm just going to solve this equation. So let's divide both sides by a sub naught. Divide by a sub naught. I get that this is 2 is equal to e to the rate times time. Take the natural log of both sides. And so I get, watch out, we know that 4 is my time, so 4 for t, here, and here. And so then I get that the natural log of 2 is equal to 4r, divide by 4, divide by 4. I get that r is equal to the natural log of 2 divided by 4, approximately 0.173. But if you want that to write that as a percent, that's the same thing as multiply times 100 and put the percent symbol. So 17.3%.